All right. So, by the way, very good morning, folks. I see Raman, Selvam, Harsha, and Prudvi already in the meeting. So, glad to be here. So, first of all, welcome to this workshop on GitOps and ArgoCD. So, today we will be talking about GitOps in general as a practice, right? And we will also be talking a lot about ArgoCD and how to use Argo CD for implementing an GitOps pipeline. Okay. And this workshop is being organized by KCD Chennai. So I'm the organizer of KCD Chennai, and I'm very glad to be able to host this particular workshop on behalf of KCD Chennai. Okay. There are some housekeeping messages that I wanted to give to you before I start the session. So for this particular session, I will be acting both as a host as a presenter, and joining along with me is Raman. And for the entire duration of the session, your microphones will be muted, but feel free to request for unmuting your microphone whenever you feel that you need to ask a question. So you don't have to actually necessarily wait till the end of the session to ask your question. So we will allow participants to ask questions then and there. Okay. And as a host, it is my responsibility to allow you to unmute your microphone and ask the question. So you can ask your question either to me or Raman while we are actually presenting. Okay. And for the very first time, we are actually recording this session. So we will see how the recording goes. And if the recording is fine, you will receive the link to this recording in subsequent email. Okay. And at the end of the session, you will receive an email from KCD Chennai with a discount code mentioned in it. So you can use that code to get a flat 100 rupees discount for the KCD Chennai event ticket. Okay. Right, so let's get started. I'm going to share my screen first. So I'll minimize all the other unnecessary applications. Oh, yes. Yeah. So yes, I have my PPT. So I'm going to like to record this computer screen. All right, so um, there is an action I need to do. So basically, my computer is asking me to restart the browser for me to allow to share the screen. So let me quit the browser. So which means I'll be kicked out of the meeting. But in a couple of minutes, I will rejoin. Okay. So please allow me to quit the browser and reopen it so that I'll be able to share the meeting. All right, so I'm back. Sorry for the interruption. So let me share my screen, and I hope you are able to hear me, right? Can you give me a confirmation in the chat that you are able to hear me? Okay, great. So let me share my screen now, entire screen. You are screen sharing, fine. So can you confirm if my screen is visible? Is my screen visible? Okay, great. So let's get started. So I will just change this to presentation mode. No, let me not change it to presentation mode. I'll change it to reader mode so that if you have any questions, I will be able to see the notification. Okay, great. So the topic for today is GitOps based continuous delivery for Kubernetes with Argo CD. And I'll be presenting this session along with Raman. So the agenda for today is, first of all, I mean, looking at the slide, I mean, don't get overwhelmed. So we will be actually gradually introducing you to concepts. And even with Argo CD, we have planned it out very well that you will be gradually introduced to concepts and there will be labs in between. Okay, so the GitOps portion of this workshop will be presented by me, and the Argo CD portion will be presented by Raman. So when talking about GitOps, I will be actually covering the birth of GitOps, how the term GitOps itself was introduced, and what GitOps is really. Okay, so there are different terms used by different organizations, and not different terms, sorry. There are different meanings, okay, used by different organizations and different vendors when they mean when they use the term GitOps, okay. But there are some core principles of GitOps. So I'll be talking about these core principles of GitOps, what are the benefits of GitOps, and the different deployments types that are possible using GitOps. And I'll be showing you how to, I'll be also talking about how to deploy multiple applications to multiple environments. And finally, I'll be talking about what CNCF is doing with respect to GitOps. Whereas with respect to Argo CD, we will be covering the core concepts of Argo CD. What are the various terminologies Argo CD uses? What are the various abstractions Argo CD provides? The architecture of Argo CD. Okay, the fundamental high-level architecture of Argo CD. There you will basically understand how Argo CD actually implements the GitOps principles. Okay, and there are various syncing models. So there is a pull model and a push model. So both the push and pull based deployments are supported in Argo CD. You will get to know the list of components, the core components that make up Argo CD. You will see several demos. So we will start with installation demo, and then we will get into different types of Argo CD applications. So, okay, so there are, you can deploy your application using plain Kubernetes YAML files, or you can actually package your application as a Helm chart and use Helm chart to deploy your application. Okay, so we will also see how to define an application in Argo CD and how to deploy that application. Okay, and then we will get into application set, and what application set is, what are the benefits of using application set, followed by a demo of application set. And there are some advanced topics or caveats that will also be discussed. Okay, and finally, you will also get to know a feature summary of Argo CD. So essentially, our intention is after the end of the workshop, you will have a very clear understanding of GitOps and a crystal clear understanding of how Argo CD works for implementing GitOps. So if you are actually um, intending to implement GitOps in your organization, or if you are intending to learn more about GitOps and how to use ArgoCD for GitOps, I assure you this workshop will be serving the purpose. Okay, let's get started. So I need to find a way how to keep track of someone who's interested in asking questions. Okay, I think I'll get a notification. That's not a problem. Right. Okay, so a little bit of introduction. Uh, my name is Senthil. I work as principal software engineer in Ericsson. In fact, I'm seated in Ericsson office now. I'm in one of the meeting rooms in Ericsson right now. And apart from my regular day job, I am the organizer of KCD Chennai. So it is on 22nd July, and it is happening as an in-person event this year. So last year it was an online event. This year it's an in-person event, and it is being planned in a big way. So it is happening in Chennai Trade Center. And I am the maintainer of an open source project called as full-fledged. I hope some of you might have known about full-fledged. I launched this project way back in 2018, and it is all about caching container images directly on the worker nodes of Kubernetes. Okay, so this will actually help users in speeding up the pod startup. Okay, even in a recent release of Kubernetes, right, in 1.27, there is a feature that is introduced in Kubernetes 1.27 in order to allow quick startup of pods. Okay, but that is not by that is not by caching container images on the worker nodes, but by allowing parallel pulling of images. Okay, okay, let's not get into that. Okay, maybe I can save that for a different session. And basically, my interests are obviously Kubernetes. I started working on Kubernetes way back in 2016, and of course, the wider cloud native ecosystem around Kubernetes. And I'm also a key learner and also a practitioner of MLOps, and I'm also a very keen learner of WebAssembly. And WebAssembly is actually being promoted, but I don't see many people having using WebAssembly in a big way in organizations yet, but mostly that will change. Okay, so that is about me, and I'll allow Raman to introduce himself when I hand over the session back to him for the Argo CD portion. Okay. All right, so let's get into GitOps. So let's begin with a basic history of GitOps. Okay, it was way back in 2017 when GitOps was actually born. Okay, so at that time there was, we have this company called as VWorks. We all know some of the products that VWorks have brought into the cloud native ecosystem. There are several products. Okay, so what happened way back in 2017 was VWorks was actually um, maintaining Kubernetes clusters. Okay, so they were having their systems, okay, in the form of Kubernetes clusters and applications running on top of Kubernetes. At that time, they were actually trying to introduce a huge change into their system, and they felt that there is a good possibility that the system would fail, that the upgrade would fail. So what happened was they stored several configurations of that entire system in several Git repositories. Okay, and then they went ahead with the upgrade, and like they feared the system failed, and there was an outage of almost 40 minutes. But luckily, they had their entire system configuration documented and stored in a Git repository. Okay, So using those configuration files, they were able to quickly recreate the entire system. So within that 40 minutes, they were able to quickly recreate the entire system, right? And this led to them thinking about how can we actually use Git and the various developer workflows that are available in Git for operations. Okay, so Git as a tool for developer was very well known in 2017. And how can we leverage Git for operations and how to streamline continuous delivery and how to actually um, take advantage of Git in operation. So that is when Alexis Richardson, the CEO of VWorks, he came out with some of the principles of the GitOps pattern. Okay, we will talk about those principles later. Basically, that is when GitOps was started, and it immediately caught the attention of the entire community. And at that time, configuration as code and infrastructure as code, they were all being adopted in organizations, and organizations were actually beginning to feel the benefits of configuration as code and infrastructure as code. Okay, and naturally, when GitOps principles were being introduced, all these things sort of gelled together, and it created a huge adoption wave. And many organizations started to consider GitOps as a way of streamlining their continuous delivery, as a way of streamlining their DevOps implementation itself. So today you see that GitOps is being practiced in many organizations, and there are a huge tool set available for you to take advantage of whenever you wanted to, whenever you are interested in adopting GitOps. And today, if you see, there is GitOps Con, an event that is organized, and there is an GitOps Days, and even CNCF has taken keen interest in GitOps. So there is a GitOps working group in CNCF and whatnot. I mean, you see GitOps being adopted. There are a whole bunch of tools available currently, right? So you have ArgoCD, which we will be talking about in this session. We have FluxCD from VWorks, and there are a whole bunch of other tools that are available for you to implement GitOps, right? So this is essentially the history behind GitOps. If you want me to define GitOps in a single sentence, right? Basically, it is a modern way to manage cloud native systems that are powered by Kubernetes. So a modern way in the sense it gives you all the advantages of it, or advantages, or it gives you various benefits. Okay, we will talk about all these benefits in a subsequent slide. But fundamentally, it leverages policy as code. Okay, policy as code in the sense configuration as code, and infrastructure as code, application definition as code, right? So once you codify all these definitions, so you take advantage of the Git repository. So a Git repository provides you with versioning capabilities. It provides you with various workflows, right? So using those workflows, you can actually define exactly how you want to introduce changes to your system, how you want to manage automatic rollbacks, how much of control you want to give to the DevOps teams, how much of automation that you want to introduce. So all these nuances and fine-grained control over how you actually manage your entire application stack is possible, um, simply because it leverages policy as code. Okay. I mean, even if you don't get this GitOps concept completely now, please hold on. I will be actually demystifying GitOps in the subsequent slides. Okay. But essentially, it was way back in 2017 when actually the GitOps term itself was introduced. So which means if you see GitOps is fairly new, okay. It is not like an age-old practice like DevOps. So DevOps practice is actually well known and it is very mature. But GitOps is actually fairly new, right? Because it was started only in 2017, and we have some 6 or 7 years, okay, of adoption or growth of GitOps scene. So there is still a lot of things that will happen in the GitOps area, okay. So when we say GitOps is a modern way of managing cloud native systems, so what I really mean is, first of all, GitOps leverages Git as a single source of truth to define every part of the cloud native system. Okay. A cloud native system, here I mean the infrastructure part, the application, the storage, the monitoring, the logging, the entire stack of the cloud native system, including the networking and all the other pieces of a cloud native system. So first thing is it leverages Git as the single source of truth. Okay. So on the one hand, you will have a Git repository, and on the other hand, you will have your cloud native system. Okay. But whatever is stored in the Git repository is the single source of truth. Okay. Your cloud native system at any point in time might deviate from what is the configuration that is available in Git. Okay. So your system is no longer the single source of truth, whereas it is the Git repository that is your single source of truth. Okay. And once you define your system and you declare it in Git, right? There is a piece called as GitOps agent, okay, which is actually a software which will be running in your Kubernetes clusters, or for that matter, it need not run internally in your Kubernetes cluster. Technically, it can run even outside of your Kubernetes cluster, but you will always see the GitOps agent running inside the Kubernetes cluster. So this agent automatically applies all the configuration, the code and policies across all the different environments. So if you have different environments, you can actually define what changes go into these environments. Okay. So there is a Git repository and there is also a GitOps agent. Okay. And whenever there is any divergence between what is stored in Git and what is actually running in a cluster, it will, I mean, the GitOps agent will alert the developers, it will actually generate an alert to the team. Okay, that is as a very first step. The alert will be generated, and depending upon your use case, you can configure the GitOps agent to automatically reconcile. Okay, so if there is a divergence, in addition to raising an alert, right, you can also configure the GitOps agent to automatically reconcile the divergence. Okay. You know the desired state that is stored in Git, and that is the single source of truth. So if there is a divergence, the GitOps agent will automatically bring the system to the desired state. So that is what I mean by reconciliation. So, okay. So that will, you can, several GitOps agents, even including ArgoCD, supports automatic reconciliation based on the single source of truth that is stored in Git. Okay. And with Git at the center of the delivery pipelines, this opens up a huge possibility because now developers can use familiar Git workflows to define continuous delivery. Okay. Um, we will talk about that later. So for instance, if you want to make a change to your cluster, let's say there is an application running in the Kubernetes cluster, right? And let's say you want to scale the application from 1 replicas to 5 replicas, right? So what you generally do in GitOps is you don't go and issue a kubectl scale command to your cluster. Instead, you go and make a change in your repository stating that the replicas should be increased to 5, and then you commit this change to the Git repository. Okay. And the GitOps agent will automatically sync this change to the cluster, and it will automatically call the Kubernetes API to increase the replica count of that application. Okay, so that is how it is done. So this is, which means basically you are using familiar Git related developer workflows by issuing Git commit and then Git push commands for you to manage the cloud native system. By the way, let me do a check if there are any questions. Okay, no questions. So some of the core principles of GitOps. So we are going to talk about core principles of GitOps. The very first fundamental requirement for GitOps is the entire system has to be described declaratively. So entire system in the sense, your entire stack of application, your entire stack that includes the application, the infrastructure, and all the other pieces that make up the entire system. You should be able to describe that entire system declaratively. So declaratively in the sense, you should be able to specify the entire system in a, let's say in an YAML file or in a JSON file or in an XML file, but predominantly it is in an YAML file. Okay, so you should be able to declaratively specify your entire system. So that is where basically you will rely on infrastructure as code. Okay, so you will rely on infrastructure as code, for instance, Terraform. Okay, and you will rely on configuration as code, for instance, Ansible, and you will rely on application configuration as code. That is, this is in the form of Kubernetes manifests and also Helm charts. Okay, so basically you should have the ability to describe your entire system declaratively. Okay, so this is, I mean, I'm not referring to having scripts. Okay, you may have some Python scripts or Bash scripts which are capable of actually bringing up your infrastructure, or which are even capable of deploying some application, but that is not declarative. Okay, that is actually imperative way of specifying your system. So GitOps cannot actually work with imperative way of describing your system or application. So you should have the ability to declaratively describe your system, which means actually you should have your system described as Terraform files like infrastructure as code. If you are using configuration as code, or if you are using some security policies, you should make use of uh, you should make use of solutions that allow you to declaratively specify the security policies. For instance, if you are using service mesh, right? So let's say if you are using Istio, then Istio allows you to specify all authentication, authorization, traffic management, all these policies in a declarative way, right? So your system should be made of tools like these, okay, for you to leverage GitOps. If in case you are using some legacy systems, right, and if you are unable to declare such systems declaratively as code, then you cannot use GitOps. I mean, you can actually do some hacks. You can actually do some hacks, and then you can deploy a GitOps pipeline, but that is not what we are talking about here. The core principle of GitOps is you should have a declarative way of specifying your system. And second core principle is this: once you have described your system declaratively, you should actually version these configurations in an immutable fashion, right? That is another second fundamental requirement. And obviously in GitOps, this is actually done using Git. Okay, so Git provides you with versioning capability out of the box, and whenever you need to make any changes to these desired system state that is existing in Git, you will have to raise a commit, right? And generally what happens is These changes are actually raised as a PR, a pull request, okay, to the Git repository, and people review these changes, and the PR is actually merged, and only then the commit gets into the repository, okay, into the desired branch of the repository. So there is a tight, there is a inbuilt versioning, of course, and then whatever is stored is immutable. So if you want to introduce a change, it has to go through a process, okay. So this is another requirement. And the third principle is automatically syncing the changes. So approved changes. So once a change to the Git is all approved, these changes are automatically applied to the system. Okay. This is a core principle of GitOps, but you can actually configure your GitOps pipeline in a way that these changes are not automatically applied, but there needs to be a manual intervention for these changes to be applied. So you can also introduce some manual interventions, which means once your PR is approved and it goes into the specific branch of the Git repository, you can have a manual, if at all that is needed, you can have a manual intervention also set up. Okay. But generally that is not the case, because our intention is to automate the entire life cycle of managing your cloud native system. And that is when you will make use of GitOps, right? So almost always the approved changes are automatically applied to the system, either by using a push model or by using a pull model. Okay, we will talk about all these different models in subsequent slides. And once these changes are automatically applied to the system, uh, it doesn't end there. Okay. So as I said earlier, what happens is the agents, the GitOps agents, they constantly check the state of the system, and they constantly check whether the current state of the system still matches the desired state of the system as present in Git. And if at all there is a change, if at all there is a divergence that is detected by these agents, an alert is raised. And you can also configure these agents to automatically correct these divergence. Okay. So which means if, for instance, let's say the number of replicas for an application, again, I'm using this replica example. Let's say in the Git, the number of replica is actually mentioned as 1. And suppose, let's say, you go to your system and then you issue a kubectl scale command and increase the number of replicas. So now, obviously, Kubernetes will instantly increase the number of replicas of that deployment. But what happens is, once that happens, the GitOps agent will immediately detect it. Okay, because it will be constantly uh, checking whether the current state is equal to the desired state. And once it detects that there is a divergence, it will go and overwrite the number of replicas in the deployment in the Kubernetes cluster. Okay. And of course, you should configure credentials of your Kubernetes cluster within the agent. And of course, only then it can do it. But you see, the principle here is it can automatically reconcile these divergences so that the current state of the system matches exactly what is defined in Git. So which means what is defined in Git is the single source of truth. Okay. This is this is a core principle in Git. Okay. So what is defined in Git is your single source of truth. So what you see in your system is not the truth. Okay. If at all you see your system diverged, right? So the duty of the GitOps pipeline is to reconcile this divergence. Okay, that is how you have to actually, this actually reflects the robustness of your GitOps pipeline, how quickly your GitOps pipeline is able to detect this divergence, and what is the kind of notifications that it is able to generate, and how quickly and how deterministically it is able to correct these divergence. So these are all actually determined by the by how you are designing your GitOps pipeline, what kind of tools you are using, how robust is your GitOps pipeline and things like that. Okay, but essentially, GitOps means you will have all these four principles. So you should necessarily have all these four principles applied into your GitOps solution for you to actually effectively reap the benefits of GitOps. Again, let me do a check if there are any questions. No. All right. All right, let's proceed. So what are the benefits of GitOps? Okay. So naturally, whatever benefits an organization reaps out of implementing DevOps, right? GitOps actually amplifies those benefits. That is how I would actually describe in a single sentence what are the benefits of GitOps. Okay. For instance, increased productivity. So naturally, right? So once you declaratively define your system and put it in Git, you have a tremendous amount of automation involved in the form of the GitOps agent automatically synchronizing these changes, which means your productivity naturally increases. You don't have to actually spend time on actually managing these deployments manually using scripts or some other tools. So all you need to do is simply push these changes to the GitOps repository. That's it. And then automatically all the required changes are automatically applied to the various systems. So which means there is an increased productivity and of course enhanced developer experience because uh, GitOps basically uses Git repository and these Git workflows of checking in code, doing a review, using Git, and then raising a PR and then getting it reviewed and getting it approved. So all these things are very familiar for developers. Okay. So which means it enhances the developer experience. So you no longer need to define separate workflows. So you can actually make use of workflows that are available in Git and which are very familiar for the developers. So in this case, it enhances the developer experience. And another key thing about GitOps is improved audibility. Sorry, it's not audibility, it is auditability. Okay, so that's a typo there. So what I mean by auditability is you can actually simply audit your system simply by looking at the commits made to the GitOps repository. You can see at what time, what changes have gone into the system. Okay, you don't have to necessarily go and check this by logging into each and every system. Suppose you have 10 different clusters, right? And if you want to do an audit, you don't have to go and see each and every system. So that is not required. You simply have to go to your Git repo, just look at what are the commits that have been pushed to the various branches and who pushed it and at what time it was pushed. So that becomes a single source of truth and improves the auditability of the system. So suppose if your organization has policies that certain changes have to be reviewed by certain group of people before it is applied to the system. So, and if you want to audit whether that policy is being practiced or not, you simply go to the Git repository and check whether that is being practiced or not. Okay. And higher reliability, this comes in the fashion of the automatic syncing capability. And this automatic syncing capability also has an automatic rollback capability. Okay. Whenever the sync fails for some reason, so naturally the syncing action can also fail, right? So if failure happens, uh, I mean, following GitOps gives you a higher reliability in the form of it can raise alerts and it can also be configured to automatically roll back the changes. Okay. So there is a higher reliability. And let's say your entire system crashes. because of some flooding or because of some other natural calamity, your entire system crashes. So what happens? You have your entire system described declaratively, and you have it stored in an highly secure GitOps repository, right? So which means you can simply uh, again bring up your system very quickly. Okay, so there is a higher degree of reliability when using GitOps. And consistency and standardization. For instance, if you are a huge organization and if you want to follow consistency, and if you want to enforce standards and policies across your organizations, then you can use GitOps, because you can actually control basically what actually gets deployed into your cluster. Okay, and if you have various environments, right? And all these various environments should always have a certain version of your application. Okay, um, so you can enforce this very easily using GitOps. Okay, so your GitOps pipeline can be built in such a way that the syncing for all these different environments happens in parallel, which means all these environments will be in the consistent state. Okay, and of course you can have standardization, because there are various things you can configure in Git. So if you are introducing a change, you can actually make sure that whatever change you are making to your system conforms to certain standards. You can have checkers. You can have checkers running and then checking these changes and all these things. And of course, there is a strong advantage related to security, because whenever, for instance, I'll give you one example. So commits to a Git repository, right? You can actually increase the security by by automatically signing these commits, okay? So that you can make sure that the change that is actually being introduced by that commit actually comes from the person. Okay, so it is no longer possible for some other hacker or someone to introduce a malicious change into the system. Okay, because the commits are actually digitally signed. So that is, I'm giving you one simple example of how GitOps can enhance your security. So you can also store your credentials as secrets, right? So that is another advantage that you get out of using Git. And basically, and of course, you will have faster development and better ops. That is one of the principles of DevOps as well. And basically, GitOps actually helps you in implementing that philosophy of DevOps. So basically, you can make multiple changes pushed into the production environment in a quick fashion. So if at all your business requires that you need to push very frequently to your production. For instance, companies like Facebook do that. For companies like Google, even Amazon, the e-commerce and all these companies, they actually push changes very quickly. So if at all your organization wants code to be pushed into production in very frequently, right? And then naturally, then the natural choice is GitOps. Okay, good. So let me now talk to you about different types of deployments that you can have in GitOps. So here I am actually presenting you about the push-based deployments. Okay. So basically what happens in push-based deployment is, um, okay, let me give you this example itself. Okay. So at the very left, you see the application repository. This is where the source code resides. Okay. So the source code of the application is residing in the application repository. Okay. And then there is an image registry. Okay. So the source code from the application registry is built using the build pipeline. and the build pipeline pushes the container images to the image registry. Okay. And then there is another Git repository here, which is called as the environment repository, or you can also call it as a GitOps repository. So this will actually have the configuration files, okay, for related to this application. For instance, it can have Kubernetes manifest files, or it can have Kubernetes Helm charts, okay. So what happens is, once the build pipeline pushes the image to the image registry, the build pipeline will also update the configuration file. For instance, it will update the image tag present in the manifest file. Okay. So what happens is, once this change is made to the GitOps repository, this will actually trigger the deployment pipeline. Okay. And the deployment pipeline will eventually deploy the changes into your environment. Okay. So this is how push-based deployments work. Okay. Whereas in pull-based deployments, what happens is, the same thing. So once you introduce a change to the code, container images get pushed, and also the configuration files are updated in the environment repository. But what happens is, there is an operator or an agent that runs inside the environment. This operator keeps polling the image registry as well as the environment repository. So if at all it sees that there is a change, okay, what happens is, this operator goes about and deploys those changes. Okay, so here it is pull. So it is the operator that makes the decision whether to pull those changes and apply those changes or not. So you can configure the operator, how frequently you need to pull the changes, what kind, and you can also configure some policies. Okay, whether patch changes should be applied or not, whether minor changes should be applied or not, or whether only major changes should be applied. So if it is a major change, which environments have to be updated first, or if it is a patch change, which environments have to be updated first. So all these policies are possible in this pull-based deployments. And then finally, the operator can also write back to the environment repository with some observations. Okay. So this is pull-based deployment. And naturally, in any given organization, you will have multiple applications, and of course, you will have multiple environments. So what happens is, all these multiple applications will result in updating their configuration files, deployment configuration files in a single environment repository. Okay. And for every environment, like there is a dev environment or a staging environment or a production environment, you can have branches created for all these environments. Okay. So what happens is, your pipeline can decide what changes have to be applied to which environments. So accordingly, the respective branches will get updated, and the deployment pipeline can actually track these branches and then deploys the application changes to the corresponding environment. So this is one way of working with multiple applications and environments. But in any given organization, you can have more sophisticated way of managing multiplication of multiple applications and environments. But this is a very simplistic way of doing it. All right. So what is CNCF doing with GitOps? Okay. So when GitOps began to be adopted and many vendors began to offer solutions for GitOps, what happened was there was no clarity on what are the core ideas of GitOps. So if at all we say that this is GitOps, whether this is indeed GitOps, or there were some confusions, and CNCF took initiatives to actually standardize what essentially is meant by GitOps. And they wanted on CNCF also was interested to define some core ideas of GitOps which are vendor neutral which are vendor neutral. Okay, rather than vendors pitching in their own products and calling it as GitOps, CNCF was interested to see what are the core principles or core ideas that GitOps needs to fulfill. So to that end, CNCF established this GitOps working group under the app delivery special interest group. So that is how actually CNCF works are getting organized. So there is a special interest group. There are multiple special interest groups within CNCF, and every special interest group will have multiple working groups. Okay, and there is this special interest group called as application delivery, has a GitOps working group, and they actually meet quite often. And then the charter for this working group is to define a vendor neutral meaning of GitOps. Okay, and you can actually look up the work that is being done by this work group in GitHub. And the very first thing they have started is this Open GitOps project. Okay, so if you go to this Open GitOps project, you will find all these specifications and principles well documented, and you will see you will see the exact meaning of all these principles, so that if you wanted to actually evaluate, let's say as an organization, you want to evaluate GitOps products. Okay, you can actually head to this open GitOps project and then see what are the principles, how each and every principle uh, should actually look like, and then look at your vendor products and see how they conform to these principles. Okay. Okay, good. I think that is it. Yes, that is it. Let me see if there are any questions. Okay, so all right, guys. I think that is it. I'm done with my part. So now I'm going to actually hand over to Raman. So I'm going to make Raman as host. Yes, over to you, Raman. I have stopped my sharing. Raman, I made you as host. Yeah.
Yeah, hello. So can you hear me?
Yes, Raman, go ahead.
Yeah, okay. So I will share my screen quickly. So I hope my screen is now showing up. Uh, okay. So I'm Raman, and I'm a senior software engineer at, at Ericsson, and I am very much interested in cloud native technologies, and I like to explore technologies like Argo CD and Selden Core. Today I will be continuing the session, and I will be sharing information about Argo CD with all of you. So let me move on to the slides. Okay, so yeah, I will start with Argo CD architecture. So as Senthil has explained, we have a GitOps repo, and as developer, you will be making some updates uh, on the manifests that are defined in the GitOps repo, and uh, and then we can like additionally configure the GitOps repo to send in webhook events that contain information about what files were changed and which branch of the code was updated, and so on. So Argo CD has a repository service that would pick up this webhook e- 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 and then it would know that what files have changed and which applications have been impacted. So it would clone that code base, and then it will apply those manifests. So that the manifest application happens by this application controller service, and also the end the users can interact with the with Argo CD via the API service. So this interaction can happen by means of UI CLI or gRPC or REST APIs. So once the manifest is being generated by the repository service, the application controller will be applying it, and it will be deployed into multiple targets, all the targets which have been configured. And also Argo CD can also send notifications uh, to Slack or Teams about the application deployment status. I'm moving on. So next I will be sharing with you some core concepts which will help you to understand about Argo CD better. So the first concept that we have is called application. So application is a CRD. CRD means a custom resource that is defined that is applied by Argo CD, and as a developer we can write this CRD spec, and it contains a source and and the destination. So the source says what is the Git repo URL, which branch that you're trying to deploy the code from, and the directory that contains the manifests, and the destination says that which cluster you're trying to deploy the manifest to. And next one is the application source type. So Argo CD supports multiple source types. You can have YAML files, or if your Git folder has a chart.yaml, then it can identify that folder has a Helm chart. If it has a customization YAML, then Argo CD can know that it is a uh, mm, it is a customized based app. You can also have plain manifests. Uh, so the target state is the state of the application that is saved in Git, and the live state is the state of the application that is currently deployed on the cluster. So and then when we do a sync of operation, we are telling Argo CD to sync from the target state to the live state. I mean, sync the target state to the live state on the cluster. So Argo CD will find out what are the resources which are not in sync, and it will be deploying those uh, onto the cluster. So I'll be showing you a demo that explains how this happens. Then sync status. So Argo CD can report to you if the live state is, ma is matching the desired state or not. So if it is not matching, then it will mark the state of the application as not in sync. You can also see if the last sync operation was successful or not. I'm sorry. Yeah. So I will be also showing you how to refresh the state of an application. So when you refresh the state, it will generate the manifest for that application now all over again, and it will try to compare and see if the state is in sync or not. Then also you can see the health status. Say if you have like multiple replicas for your deployment, are all the replicas up? Is the state healthy or not? Okay, I'll be going ahead. So the sync modes. Hello, is my screen visible? Okay. Hello. Okay, thank you. Yeah, so there are two modes, sync modes, which are supported by ArgoCD. So ArgoCD can find out if there are changes made in the Git, and it can mark the application as as out of sync, but it will not apply the the, uh, the changes directly if the sync mode is manual. So either we we have to uh, trigger the sync manually, or we have to have some sort of CI/CD pipeline from which the sync command can be triggered. And also there is an automated sync mode wherein as soon as Argo CD will find some changes in Git, it can it can pick those manifests up and then deploy them automatically. And also, if you make some changes in the live state without updating in Git, Argo CD will find that out and it will mark it as out of sync. And you can also mark the app to self-heal. So if you set self-heal, if you make any changes directly on the cluster, uh, Argo CD will overwrite that changes with whatever is defined in Git. And also, uh, uh, you can set auto prune to true, which means that if you have made any changes to the manifests, uh, or if you have removed some objects between uh, versions, then when Argo CD deploys the new version, it will prune those resources which have been removed, which are no longer in Git. Say like the V1 of your app had some 10 manifests, and it created some 10 objects, and then when you're deploying a V2, if you have removed some four objects, then those four will be removed automatically. If this auto prune is not set, then Argo CD will not remove those four uh, like obsolete objects. Okay. So Argo CD applies manifests in phases. So we have three uh, phases defined: pre sync phase, then the sync phase, and then the post sync phase. So if you're familiar with Helm, this is like very much similar to the Helm hooks, where you have pre-install, then post-install, and so on. So to mark to mark a manifest as a hook, you have to add this hook annotation. And if you don't have this annotation added to manifest, then it means that it is part of the sync phase. Okay. Next, so like within a phase, if you want to enforce the order in which the manifests are being applied, then you can add the sync wave annotation. So sync wave is similar to the Helm hook wait. So the sync wave wait, I mean, like it, it applies the weight in which to 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 each manifest. So the manifest with the lower sync wave value is like applied first, and all manifests have a default sync wave of 0. So if you don't, if you have some manifest that does not have this annotation, it is assumed to have a value of 0. Okay, I'm going ahead. So as Senthil has told us about pull and and push model, the same model can be set up in Argo CD as well. So in pull model, Argo CD will be continuously polling the Git repo for changes uh, every three minutes, and so Argo CD has this like additional overhead of polling the repo. in the push model, we can have a stage in our CI/CD pipeline to run a sync. So for this, you can use the ArgoCD CLI. So we have a subcommand called app sync, and we have to pass the app name. So then ArgoCD will be like automatically applying the changes. One more way is to have a webhook configured in your Git repo, so that whenever you are pushing changes, there's a webhook sent out to ArgoCD, which and then ArgoCD can apply whatever changes have been made in the commit. Okay, going ahead. Okay, so now I'm just showing you how to set up the webhook, and to set up this webhook, your ArgoCD instance has to be exposed by an ingress, so that it can be reached from the Git provider. So here in this picture, it is assumed that mm, 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 ArgoCD is exposed at argocd.example.com, and the payload to the webhook will be sent to the /API/webhook endpoint. And also we like ArgoCD can validate that the webhook is being invoked from the correct Git provider by specifying a secret. So this secret has to be also set in the secret in the ArgoCD namespace. So as you can see here, web I just saw a question. So this value set in both in the Git repo as well as in the secret. And as you can see here, currently only GitHub, GitLab, Bitbucket server, and GOGS are supported. If you are not on, if you have a Git repo which is not on these, then you have to you cannot do the push model with webhooks. You have to use the pull model, or you have to have a manual, like pipeline wherein you run the sync command. Okay. Yeah. Next. Yeah, so here I am showing, so this picture is showing you how you can run the sync command from your CD pipeline. So we will be like pushing an image to that image repo as part of the build process, and the same image tag is going to be updated in your manifest, and then in the CD pipeline we will be invoking ArgoCD sync command, and then the changes can be deployed onto the target environments. Okay. Yeah. So next, I'm going to be explaining a bit about each of the components that are a part of ArgoCD. So the first one is API server. So it exposes all the endpoints, and these endpoints are consumed by the web UI and the CLI. Okay, so and you users mainly communicate with ArgoCD via this API server. So all the actions like sync, rollback, and all are done by the API server. And you can add private Git repositories or your clusters into ArgoCD via the API server, and these the Git repo information like passwords and SSH keys are saved in the form of secrets. The API server can also integrate with OID DC providers like Keycloak and Dex for authorization. And if you have set up roles and groups inside, okay, 1 second, I have to unmute Senthil.
Yeah, thanks, Raman. Please proceed.
Okay, yeah. So I was. So if you have configured if you have configured single sign-on, then, and if you have defined some groups inside the OAuth provider, then you can use you can configure RBAC saying what permissions are allowed per group, and the API server will be enforcing those rules. Then whenever Git webhook is sent, it is received by the API server and it is forwarded to the repository service. Okay, moving on. Okay, so as we have seen in the architecture slide, the repository service is responsible for generating Kubernetes manifests when it is given with the repository URL, the revision, the path from which manifest have to be read, and templates specifying settings like the values YAML or like customization parameters. So it will read all this information, and then it will detect the type of application, and it will build manifest if it has to. So say if you have an Helm chart, it will use the values file, and it will generate templates, and those templates will be cached into Redis, and from there the application controller can take it and deploy. So the next up I have the so the next component is application controller. So it is it will be continuously monitoring for application resources, that is CRD, and then it will be comparing the live state with the desired state, and it can take corrective action. And next up, we have an application set controller. So in many scenarios, we would want to deploy the same application into multiple environments. So if you are solely going to depend upon the application CRD, then for each environment where you want to deploy the application, you have to write a separate manifest. Or for the sake of simplifying the automation, ArgoCD has introduced this application set CRD, wherein you can have uh, you can have a template, and then you can specify that the template has to be deployed onto multiple environments. So the uh, mm, the application set controller looks at such application set specifications, and it generates application manifest based on the application set specification. So it is very useful when you want to deploy the same application into multiple environments, and if you want to deploy multiple applications at once into a cluster from. So I'll be showing examples of how this is very useful for automation, and also since with application set we can generate application manifest on the fly from a Git repository. Uh, uh, the developers don't need access to the mm, 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 to the cluster, so they just have to have access to the Git repo, and the cluster admin can recreate a application set, and and uh, uh, and as and when there are commits into the Git repo, new new applications will be created on the fly. So I will be showing a demo that explains this further. So okay, the final component which I want to cover is notifications controller. So Argo CD can send updates to services like Slack, Teams, whenever the state of an application changes, and we can also configure some templates that correspond to each state. So the application has to be annotated with this annotation. So as part of this annotation, we say which event triggers this notification, and which service, and who is the recipient of this notification. So this controller will be monitoring all the applications which have this annotation. Okay. So I will be showing a quick demo on how to install, and then I think we can take a break. Okay. So
Yeah, Raman,
yeah,
how many minutes will the installation demo take?
it should not be more than 5 to 10 minutes.
Okay, then it's fine. Proceed, Raman.
Yeah, so I have a Git repo. I will be sharing this Git repo details and the slides at the end of the session. So I have set up a local multi-node minikube environment. So I have like executed these comments already, and I have also added some add-ons. So you can see that I I have a three node cluster. Okay. So next, what I'm going to do is so Argo CD can be installed in multiple modes. Uh, uh, you can have a multi-tenant installation, or you can just have a core installation. The core installation is uh, is preferred by admins when they just want to to use Argo CD for like bootstrapping the cluster, and they don't want to add on multiple developer teams, and multi-tenant uh, uh, way of installation is used when you have multiple users who would be creating applications. So you can uh, 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 choose between multiple ways of installation. You can have you can do a manifest based installation. You can use customize. You can have the community Helm chart, which in turn adds on uh, uh, which in turn adds on HA proxy and Redis as dependencies. So I'll be demoing the standard HA install with manifests. So first I have to create the namespace. So namespace is created. Now I'll be applying the manifest. So we can see what are the applications. I mean, what are the manifests that got deployed. So you can, I'm just checking the pods. So we can see here that I spoke about application controller, application set controller, and notifications controller. And I spoke about repo server, and I spoke about Argo CD server. All these pods are now coming up, and and additionally we have this uh, Redis HA that will cache the manifests that are generated by the repo server, and also we have DEX which can be configured for OIDC if you want to have single sign-on. I'm just waiting for one instance of each pod be up. Okay, so now I can connect to this ArgoCD environment.
Raman, one question.
Yeah.
The repo server that you showed, right? So it is using Redis for caching the generated manifests, right?
Yes, you're correct.
So, Argo CD will support only Redis, or does it has support for other data stores?
No, I think it only supports I mean, it can only support Redis. So you can see the YAML here. It will have it has this parameters and all set. So it does not support anything
Oh,
other than Redis.
okay. Okay.
Yeah.
And another question,
Yeah.
also related to the repo server. So this repo server is basically it holds the copy of whatever is present in the GitOps repository in the Redis cache, right? I want to understand. I mean, is it like an exact replica of the GitOps repository, or is it It just processes and
Yeah,
then.
I can explain. So when you are defining an application, you have the source defined in the application manifest. So that source is going to be a Git repository, and it has a branch, and it has a path path which is defined where I mean from which the manifest it has to be pulled in. So the repository server, what it will do is that it maintains a clone of that source repo,
Hmm.
and it will check the folder. So if if the folder has a Helm chart, or if it has something like customization YAML, then you cannot directly deploy it. You have to first you have to first get the manifests. So if it's a Helm chart, it will do a Helm template, and it will get the manifest, and those like generated manifest will be cached in Redis.
Okay. Okay, understood. Okay, fine.
Yeah. So it is 12 now. Should I continue, or
Yeah, we can
uh,
take a break now, Raman, and then
okay?
we can continue after the break.
Okay.
Okay, I would suggest that we take a break of 10 minutes and then return back at 12:10. Okay, thank you all. Meet you all in 10 minutes.
Thank you. Hi, Senthil. I'm trying to unmute you. Hello.
Hi, Raman.
Yeah.
Okay, we can get started, Raman.
Okay. So I have now deployed ArgoCD. Now we will see how to access an ArgoCD via the CLI. So for this, you have to install the ArgoCD CLI. So the steps are there in this Git repo. So as you can see here that I have installed 2.7.2. So you have to match the CLI to the same version. So once you download, so if you go to the page releases page, you will find CLI for each an operating system. Then you can select whichever one that you want to install. Uh, yeah, assets. So from this you can select the link and then you can install it. So I have done this already. I have downloaded for Linux and I have saved it in my path. So now I can check if it is installed, if it is installed correctly. So next I will try to access Argo CD via the CLI. So first I'm going to port forward the Argo CD server service. So you can use kubectl port forward command also, but since I'm on the Minikube, it gives this convenience function. So let the so I cannot do anything else on this terminal, so I will let this run here, and I will note down this host URL. I will let me copy from here. So we don't need to give HTTP or HTTPS, just the IP is enough. And next, we have to get the secret for the admin user. So this is saved in a secret called ArgoCD initial admin secret. So we can use this. So I will save that also into a variable. Clear screen. So okay. Now I will run the login command. So password is in ArgoCD admin secret. Also, we have to use insecure since it is running on local and I have not exposed it via HTTPS. Okay. So I am like getting this my message that says that I have logged in successfully as admin. So Argo CD will save this context in inside your home folder. Argo CD. So there is this config file. So here you have all the contexts and what is the token that it has been retrieved for you. And the CLI will be managing the auto refresh of this token. So I can also list the contexts. So now I'm right now connected only to one context, and I can also run some commands. So I have not deployed anything, so I don't have any apps running. So next I will show you how to access the UI. So let me.
Raman, one question.
Yeah.
In the terminal, actually, it showed two different URLs for the Argo server, right? One with port 37909 and another with port 33035.
Yeah. So go back here. Sorry, service. Yeah, so you have both HTTP and HTTPS port. So since I have not secured, I have not secured it via certificate, both of them are now insecure. So I can use any one of those.
Okay.
Okay, so the password I have to copy from here. So I mean, this is the Argo CD UI. All the applications that you deploy will be shown here. And I will also walk you through some settings which are available. So you can connect to private repositories. It can be Helm or Git via SSH or HTTPS. If you have GitHub, you can also connect to a GitHub app via Google Cloud, etc. So whatever you set up here, it will be saved in form of a secret in the server, in the cluster. So right now for the demos that I will be doing later, I will use only public repository, so I don't have to set up anything here. But just for your information, if you are setting up any private repository which you want to configure in your application as a source, then you have to set up a repository here. Okay. Next thing that is so Argo CD comes like when you're installing Argo CD itself, the known hosts file is populated with the cert info of all common Git providers. So this means that you can clone without any certificate issues or any warnings. So if you want to add more, you can do it by clicking these options. So this also gets stored as a secret in the cluster. Next up, we have, so if you want to restrict that only commits from, like only signed commits have to be pulled, then you can add the commit specific credentials here, so that only known committers commits will be pulled. So you can also add more clusters. So by default, you will see that we have in-cluster configuration added here. So it is showing unknown right now, but when I deploy the first application, I think this will change. So you don't have any option to add it, add more clusters from the UI, but with the CLI you can clear ArgoCD context. You can add a context here. Sorry, ArgoCD cluster add. Sorry. So this the CLI can read your kube config and then add the context. I mean, it can access the server details from your kube config, and it can add that into the cluster. So what happens is that the backend it will create a secret, and that secret will be annotated in a particular fashion, so that ArgoCD knows that it is corresponding to a cluster. So the kube config of that context will be saved as a secret, and it will be listed here. Okay. And it is also possible to configure projects. So by default, we only have one. We can add more, and when we add more, so let me show you here. So you can say, I mean, you can whitelist or blacklist source repositories, and you can allow say if your application manifest has this, I mean, your application manifest will have a field called the project that says which project it belongs to. And so right now I don't have any restrictions set, so I can deploy from any source onto any destination. But if I want to limit, I can change the settings here. Okay, and I am allowing all sorts of manifest. I don't have any deny rules. And if I have connected to single sign on, and I have set up OID DC, then I can set up some role specific rules, and I can set up some sync windows. Like I don't want the application to be synced as and when the change happens. I can set up a sync window so that the applications that belong to this project will be synced only in this particular sync window. Okay. So you can also create some more accounts. So for this, you have to edit a config map. So all these are, since I have not connected to any single sign-on service, all these are local accounts. And you can also turn on dark mode if you are a fan of dark mode. Okay, so now I will continue with the PPT. So I will walk through some sample applications, and then we will look at how to deploy them with the demo. Okay, so the demo is done. So now we will look at a sample manifest. So so here in my screen, I'm showing a sample application manifest. So all the application manifests have to be applied in the ArgoCD namespace where ArgoCD is running. But the manifests that correspond to this application can be applied to any namespace. So here I'm I am specifying that I want this manifest to be deployed. I mean, the manifest that are picked from Git to be deployed onto the namespace guestbook, and I want it to be deployed on the default cluster where ArgoCD has been installed. And I'm also saying that this application belongs to the default project, and the source source of manifest for this application is this repo, and within this repo the manifest have to be read from guestbook, and the target revision is head. So head, so some Git providers use master, some use main. So you can use head to be consistent across Git providers if you want to point to master or main. Okay, so whenever there's a new so, and I have not set any sync modes here, so it will be it will use manual sync. So ArgoCD will find out when there's a new commit, but it will not apply the changes unless we issue a sync from the UI or CLI. Next example.
Raman, one question
Yeah.
from me.
Yeah.
Can ArgoCD deploy an application to a cluster that is different from the cluster in which ArgoCD is running?
Yeah. So
Right?
for that, I just explained that in the session. So okay, let me. I have a few contexts here. So, so all these contexts are like defined in my kubeconfig. So I'm not changing the context, but I can add a cluster to ArgoCD by just specifying the context name.
Okay.
So what it will do is that it will read my kubeconfig and find that context specific information, and it will create a secret, and that and that kubeconfig information will be saved into a secret, and it will be shown. It will be visible in the the cluster list.
Okay. Okay. Thanks.
So you can give the name. In that case, you don't have to specifically give the URL. You can give the name as well. So in the examples which I am showing, since it is in cluster, we are I think we are just like giving the URL.
Okay.
Yeah.
So if it is an cluster that we added using the Argo CD CLI or the UI, then in the application manifest, we just have to give the name of the cluster, right? No need to give the namespace and the server name.
Yeah. I think both. I think both of them work, but in all the examples which I have seen, they give the URL.
Okay.
Okay. So next example that I have is deploying from a Helm registry. So so here you can see that the destination is similar, but the source has changed. So source here, I don't have a Git repo, but instead I have a Helm registry, and the target version is a Helm is a Helm chart version, and I have some values overrides which I have applied inline. So here I have also added sync policy automated, and I want this application to self-heal. So if I make some manual changes, ArgoCD will find out that the state of the application has diverged from the saved state in Git, and it will heal. It will sync to the saved state in Git automatically. And if I don't have this namespace uh, available, then I can ask ArgoCD to auto create it while it is doing the sync. So the disadvantage here is that since none of the source is from Git, I cannot version this. And if I have to change any like Helm parameters or something, then I have to come and edit this application manifest. So this does not obey the GitOps principles. So to deploy a Helm chart in a GitOps native fashion, I will be explaining one more example. So that is the next example that I have. So what I can do is that I can wrap up, I can create a temporary Helm chart that has uh, the Helm chart which I want to deploy as dependency. So and I can have a values file wherein I can specify the overrides for this chart, and I can check in the chart.yaml and the values.yaml into Git repo. So now my manifest will just look like it will pull from Git. So so when I have done a commit, then Argo CD will pull this, and it will see that there's a chart.yaml. So it will run Helm dependency build, and it will fetch this chart, and then it can run Helm template, and it can generate manifest, and it will save that into Redis, and and then the manifest can be applied. So in this way, we can do a Helm chart deployment in a GitOps uh, native fashion by defining a temporary chart that has the chart which we want to deploy as a dependency. Okay. Next, I have a
Uh,
beta.
Raman,
Yeah.
one
Yeah.
question.
Yeah.
So within the application manifest, right, so there is a destination field, correct? So
Correct. Yeah.
this destination field, it doesn't looks like an array. So I want to understand, is it possible to specify multiple destinations? Meaning, I want this application to be synced to multiple clusters.
So an application can have only one target. So Argo CD came up with the application set CRD for the uh, use case in which we want to have a single application deployed into multiple environments. So
Okay.
I have slides for that later. I'll
Okay.
be I'll
Understood.
be I'll be covering that.
Yeah. Thanks, Raman.
Yeah. I mean, moving on. Uh, so the challenge with this approach, with this approach was that I cannot give the values file from Git. Uh, so what Argo CD has done is that they have added a beta feature uh, wherein I can have multiple sources. So the first source is a Helm repo, and values file for the values file, we are telling Argo CD to refer this Git repo. So from this Git repo, it will pick the values file from this path. So this is a beta feature, and I think there are many bugs reported with this. It's not very stable yet, but this was a feature which was asked by, I mean, which was requested by many Argo CD users. Okay. There is one more way of having multiple sources. Say you have a third-party Helm chart, and you want to like override some of the manifests. So what you can do is that like whatever manifest which you want to override, you can add them into Git repo, and Argo CD will be rendering manifest from both the Helm repo as well as from the Git repo, and whichever source has been defined last, the manifest from that repo will take precedence. So if I have the same, sorry, if I have the same group kind and name and namespace from both the sources, the source which is defined last will take uh, priority. I hope it is clear. Yes, I'm going on. So next I have an applications demo. So I explained some scenarios in the slide. So I will be trying to showcase them. So first I will be deploying an application via the CLI. So ArgoCD has this app create. Okay, so there will be some examples here which I can show you. So you can specify repo path, uh, namespace, server, etc. As command line arguments, and the CLI will convert this and into an applications manifest, and it will submit it to the API server. So in the Git repo, I have a guest book application. So I have as part of this application, I have a deployment and I have a service. Okay, so I will be running a command to deploy this. So, okay, so I have specified the path, the repo, and the namespace where I want this manifest to be applied, server where it should be applied. And since I don't have this namespace available, I'm telling ArgoCD to create it while syncing. So the application is now created. So if I do kubectl get applications, it will be showing. So here you can see that it is out of sync, and since it is not in sync, it says that it is missing. The health is missing. So I can also fetch the same information using get, or you can also see this in the UI. So it has like it has found out that this application has a service manifest and it has a deployment manifest, and it has marked it as missing. So now I will trigger a sync. So first it created the namespace, and then it tried to create the service, and then it tried to create the deployment. So now if I get it again, it shows that the deployment is still going on. So you can see the same thing in the UI. So I have only specified a deployment and a service. I have not specified these things. So since these are like automatically created by the deployment and service, you have an endpoint and then replica set, etc. All of these are also shown here. Okay, now let me do one thing. I will scale up the deployment. So I have only one replica, but I'm going to scale it to 2. So you can see here, like immediately it is marked as out of sync. So this you can actually filter out resources which are out of sync here. So it shows here that this guest book UI is not in sync. So, and I have not set sync policy. So if I like enable auto sync, it will get synced up. It will get fixed immediately. So instead, I will, for now, what I'm going to do is I will run the sync manually. So the replicas got reduced. And one more thing which I forgot to show you is that if I scale up this, and if I click on this manifest, it will show me both live as well as desired state, and I can check out the diff. So the diff is shown here. So in the live state, I have 2 replicas, but in the Git, I have said that I want only 1 replica. So I can do a partial sync also. So if I click on this, I can do a partial sync also. I don't want to sync the whole app, but only the resource which is not in sync. So I can click on synchronize here and it will apply. Okay. So now I will delete this app. So ArgoCD app delete guestbook. You can verify now that if I get applications, it will not show anything. And it is also now gone here, showing that application was in fact deleted. Okay. Next step that I wanted to show is to how to deploy an application via the UI. So for this demo, I have a Helm chart. This Helm chart, has dependency on Bitnami sealed secrets chart, and I want to also change values parameters. So I have defined that here. So I will be showing how to deploy this app via the UI. So you can go here and click on new app. It will ask you to enter the application name. So application name, just to give me a second. Application name is sealed secrets. Project name you can use the same default, and sync policy I'm going to set as automatic. I'm also going to turn on these 2 options. So if there are any extra objects which are left behind by old versions of this application during a sync, they will be pruned. And also if there are manual changes done on the live state and which is deployed in the cluster, Argo CD can self heal. In some cases, we would also want to add some more of the sync options. I encourage you to read the documentation to like understand more about these sync options. For now, I only need this option. So like when you are pruning resources, you can use foreground background or like orphan. So background means first the parent. Say if you are deleting a deployment, first the deployment is removed, and then the pods that make up the deployment get deleted. If you use background, it means that first the pods get deleted, and then the parent deployment. So I'm going to give my Git repo as the source. I'm just getting the Git repo name. So it has found out that only the head, I don't have like any other branches. If there were multiple branches, then I can select it from here. Then the path that I want to use is this apps sealed secrets. I want to deploy this in the same cluster where ArgoCD has been installed. And the namespace which I want to use is sealed secrets. And ArgoCD has found out that this is a Helm chart, and it has read the parameters which I have specified in the values file, and it is showing this as overrides here. I can also supply, like instead of filling in this form, I can also fill in YAML. Yeah. So clicking on create. So it is syncing, and meanwhile I will show you the logs of the repo server so that you can see. Okay, so
Raman, one question. So in the previous example, right, where you had one deployment and one service, so you created the application using the CLI, right?
Yeah.
So the moment you created that application, it did not sync automatically. But in this example, the moment you created the app, it automatically synced.
Yeah, since I have set the sync policy to
Okay.
automated.
So automated prune to true and self heal to true, right? These two
Yeah.
flags. Okay, understood.
Okay. Yeah. So I just wanted to show this log here. I hope it is visible. So you can see here that this repo server has added this repo as a source, and it is doing Helm dependency build, and it is running Helm template. So it actually generates all the manifest, and then it is saving it into the cache. Okay. We can do one more change. So I have the sealed secrets namespace for deployment. So if I scale this to 2, I scale it to 2, then ArgoCD immediately will scale it down back to 1. Okay, I think it is taking time. Okay, so we can check. I can see what all things have happened here. So sometimes when this the state is not getting updated automatically, you can click on refresh. Okay. Okay, just a second. I'm checking. Spec dot containers. Okay. Actually, it is supposed to detect it, but in this case, it has not detected it. I can
So it
sync.
is supposed to auto detect it and auto heal it, right?
Yeah.
Okay.
I guess there is some issue here, but it works normally.
Hmm. Okay.
Okay. Yeah, I'll just move on.
Yes.
Okay, so I can delete this application. Application in namespace ArgoCD. The application is now deleted. Okay. Yeah, moving on. Next, I will talk about okay. Next, I'm going to talk about application sets. So there are many scenarios in which we want to deploy the same application into multiple target environments. So it will be, I mean, so Argo CD has come up with the application set CRD that helps us to uh, that helps us to define an application template and pass parameters to the template. So the first, so in this spec, you can see that I have a generator and I have a template. So this template part actually contains the application definition, and the generator is the one that supplies parameters to this template. So here I have like uh, I have a list of of elements, and each element has a cluster name and the URL. So when I apply, so when the ArgoCD application set controller applies this list to this template, we will get three manifests. Sorry, three application manifests: one for engineering dev, one for engineering prod, and one for finance pre-prod. And the URL will get replaced here. So the parameters that can be supplied are have been, so you can only use the parameters which have been defined here. You cannot have any other parameters in your template. So this is the list generator example. Okay, similar to this, we have a cluster generator. So uh, in the in in the demo, I was like explaining that we can add more contexts to Argo CD, and each context, each cluster gets saved as a secret. So we can specify that we want to deploy an application to all the clusters which have been configured inside Argo CD with this generator. So Argo CD in turn will look for all these secrets, and it can get parameters like name, the name normalized. So if it has any hyphens or something, it will get removed. Then the server URL, and if you have any labels or like annotations which have been specified in the secret, all of them can be used as a template variable. So in this example, we are having name and the server. So you will have the name slash. So if you have four, four contexts configured, then the name will be picked from the secret corresponding to each context, and it will substitute here. And the server URL also is going to be picked from the secret. Okay. Next up, I have the Git generator. So there might be a scenario where you have multiple app manifests which are saved inside Git, and you want to deploy all of these at once into your environment. So what you can do is that you can have a Git generator. In this manifest, you have the Git repo URL specified, and you can say which paths have to be considered. So here I am showing you the add-ons directory. So we are telling the application set controller to parse all the subfolders inside this add-ons directory, and we are also saying that exclude this directory. So and in the template we can use all these parameters: path dot base name. So here the base name is going to be as the name of the folder, and the path will be like the absolute path. And you can also, if you have like bunch of folders, you can also select particular folder with the I mean by specifying the entry number. So if you have like four folders, you say path of 2, then it will get the second path. So this is like very beneficial for admins who don't want to give the deployment access to the developers. So the developer can simply check in his code changes or the manifest into a folder inside into a subfolder, and then it gets automatically deployed. But the admin should like monitor all the pull requests and then make sure that malicious manifests are not being like committed into this code base. Okay. Then there is one more generator called metrics generator. So here you can see that we have specified multiple generators. So I have a Git generator as well as a list generator. So what happens here is that we I mean the ArgoCD application set controller will do a Cartesian product. So I mean to say that it will find out all the folders from Git that have manifests, and it will also read all this uh, list elements to find out where those manifests have to be deployed. So and in the template we can use the parameters from both these generators. I hope it is clear. Okay. Moving on. So there are a bunch of more generators in ArgoCD, which I'm not covering in this session. So you can I think I have just covered the basic. Yeah. So next I will be going through a demo of this application set as well. Okay. So so I have a folder called application sets here. Okay, before I start this, I just want to point out that I cannot add an application set via the CLI or via the UI. So I have to specify a manifest, and then I have to apply it via kubectl. So the first example that I have is for a list generator. So I have specified all the paths wherein I have apps as list elements. And I have also specified what is the app name that I want and which namespace it should be deployed and so on. Okay, so yeah, so in the template, I can use app name, I can use path, and I can use namespace, and I can also, if I want to give like sync policy also, if I want to like customize for each of these elements, I can add sync policy. I mean also as an entry here. So I can now apply this. So, We'll apply application set list generator. Apply -f. So you can see that it like automatically picked up and generated the application manifests. So this is a new app which I have not shown to you in the earlier demos. So in this app, you can see that there are some hooks. So this hook is annotated with pre-sync. So this hook gets created upfront, and this hook you can see that it is a sync hook. So it will run after the pre-sync hook runs. Okay. So I do kubectl get applications. I can see three new applications here, but I have only applied an application set. So these got automatically created. So let me show you the pod logs from application set controller. So here it says that it created 3 applications. Okay. And just give me a second. I'll be right back. I'm getting a call. Just a second. Sorry for that. I'm back. Let me share in again. Yeah. So now I can delete this application set. And now automatically the applications should be removed. We can see you can see that all the applications got removed. Okay. Next example that I have is for the Git generator, which also it generates the same applications. But here, like instead of the list generator, I have used the Git generator. So I specified the repo URL as workshop as the same repo URL, and I have asked it to iterate the apps directly, and I have told it to exclude the sync waves directory. So from each path, it will pick up the path dot base name and the path parameters, and it will substitute and it will create the application manifests. Okay. So let me quickly apply this. So you can see that the application got created. Check the So now the application set controller has cloned the Git repo, and it has checked the Git repo, and it has created it has found the sync waves, but since I have an exclude parameter passed, it has not created application for that the directory. Okay. So now let me try one more experiment. I will go to the guest book namespace. So deployment. Okay. I'm going to scale this. Yeah, as soon as I scaled it up, it got turned. I mean, it got scaled down. So we show it to you again. We try detail scale deployment guest book UI. So as soon as I scaled it up, it got scaled down since I have set heal. I have turned on self heal. Okay. I can show you one more thing. So if I delete this application, so when I'm deleting the application, I have to confirm the name of the application which I want to delete. So when I'm deleting it, as soon as it gets deleted, the application set controller will recreate it. Okay. Yeah, we can clean up the cluster. Okay. That brings us to the end of the demos. I will continue with the PPT. Okay. Next, I will be covering some learnings which I have got better by trying out ArgoCD. So some of these are like behaviors which we don't expect. So it would help you to debug applications. Okay. So So when you're deploying an Helm chart via ArgoCD, so your Helm chart might contain some hooks, but ArgoCD does not know if the chart is being deployed for the first time or if it is an upgrade or if it's a like rollback or something. So for ArgoCD, all operations are a sync operation. So all the Helm hooks that you have in your Helm chart will be applied always. So if you have some pre-installed, pre-upgrade or post-upgrade hooks, they're all applied at
Raman,
whenever you're running
one
a sync.
question on this, Raman.
Yeah.
So if I have a Helm chart
Yeah.
with Helm hooks, right?
Yeah.
So when I mean, can Argo CD convert those Helm hooks into corresponding Argo CD hooks?
I have a slide that explains which hooks are supported. So I just wanted to highlight that. So like when you're doing a Helm install or a Helm upgrade, only the pre-install or like if you're doing an install, only the pre-install and the post-install hooks run. If you're doing an upgrade, only the pre-upgrade and the post-upgrade hooks run. If you're running those commands via the Helm binary, but when you're installing the Helm chart via Argo CD, all all hooks are run always. Since
Okay.
ArgoCD does not differentiate between install and upgrade. For ArgoCD, everything is a sync operation. Okay, so your hook has to be idempotent. When I say idempotent, I mean that you should not use functions like rand alpha num etc. That like in each template, like whenever you're running a Helm template, it will like give you a it will give you a different output. So the target state or the state which is saved in Git is not is non-deterministic. It will keep changing as and when you run a template. So like when you are trying to do a sync, the repo server will first run a template Helm template command. So that Helm template command should always give you the same manifest output for a single Git version. So since all the hooks are running in as part of each sync, it is it is recommended to like annotate the hooks with a weight. The CRDs can have a weight of -2. Pre-install and post-install hooks can have a weight of -1. So like this will mean that the CRDs get installed first, and the pre and post install hooks get installed later. We can also add hook delete policy. So this table shows which Helm hooks are supported by ArgoCD. So if you have if your Helm chart has a manifest that is having a hook annotation which is not supported by ArgoCD, then ArgoCD will treat that manifest as a normal manifest. It will not treat it like a hook. So things like pre-delete, rollback, etc. are not supported. Okay, so I hope this is clear. I'm moving on. Okay, so now consider that you have a repo that has multiple application manifests. So like the repo which I was sharing. So in this repo, I have multiple manifests. So suppose if I create three different applications with the same source repo, and I'm deploying it onto Argo CD. Now, if I change one of these repos, Argo CD will not know which application has changed, since there is a new commit to the Git repository. It will try to sync all the three applications at once. But the change which I made was only to this particular application. So we can actually add an annotation to our application to make Argo CD aware that which folders are being used by what applications. So I will explain that in the slide. So we can add this ArgoCD .argoproj.io manifest generate paths annotation, so that in the example which I was explaining, only the guestbook app gets synced again, and not the other two apps. So an example for that is you can add this annotation like this. I hope this is. I hope you can see this. So here in this example, I have added the absolute path. In the below example, I have added the relative path. It is also possible to add multiple paths. You have to add a semicolon as a separator. So in this case, what would happen is that when there is a new commit, ArgoCD will be like getting a webhook, and that webhook will contain the information of which folders have changes, and then ArgoCD can look up this label and then determine which applications have to be synced. So if you don't have this annotation setup, ArgoCD will be syncing up all the applications that have the Git repo as source, irrespective of whether there are changes made to that application. Okay, so with this, I'm coming an end. I'm coming to an end to this session. So I would like to quickly recap all the features which I have demoed, and some of these I could not demo since I have deployed ArgoCD onto a local environment. So we have seen that that ArgoCD can be used to deploy applications to specific environments. We can deploy multiple types of apps. You can use customize Helm, plain YAML, etc. We can deploy to multiple environments. We can actually integrate ArgoCD with SSO. But for this, I have to have ArgoCD exposed as a service which can be accessed from outside. So and we can roll back or set the version. So if I have multiple commits, and if a new commit broke the build, then I can roll back to an older commit. So the health of each application is shown. Then we can also see the config drift, the UI. So it shows when it marks it marks resources as out of sync whenever there's a change made in the cluster manually. We also saw about the CLI for automation and the CI integration. I also explained about the webhook integration, and we also saw the pre-sync, sync, and post-sync hooks. So this audit trail, like whenever we are deploying an application and whenever sync happens, so all the operations which are performed by ArgoCD is printed in form of events, and the ArgoCD components like the application controller and all emit Prometheus metrics which can be monitored. And I also explained about how to deploy a Helm chart and then have some parameter overrides in Git. So with this, we come to end of this session. So if you have any further questions, we can discuss them now.
Thank you, Raman, for this nice presentation about ArgoCD. I have one final question to you, Raman.
Yeah.
So, similar to ArgoCD, are there any other tools that are that have comparable features like with ArgoCD? I know there is something called FluxCD.
Yeah.
You are
So
other
Flux
tools
CD, I think, is the most I think comparable to
to Argo CD.
yeah, to Argo CD. So in Flux, they have a different approach where they define everything as a CRD with CRD. So the Git repo, the cluster, uh,
Mm.
all of them can be like defined with the CRDs.
Mm-hmm.
So the Argo, why like Argo CD is more preferred is because Argo CD is part of the Argo project.
Mm.
So I can show you here. So they have like bunch of things like Argo workflows uh, and, and and Argo events and
Mm-hmm.
Argo rollouts. So Argo CD plays well with all of these.
Okay.
So if you choose Argo CD, then you can choose more tools from the Argo e, e, system.
Okay.
So I will also share this code base in the chat, and
Sure.
after this, I will be uploading the PPT to the same code base.
Okay. Thank you. Thank you, Raman.
Thank you. Thank you for this. Opportunity.
Yeah, yeah. No problem. Okay, Hall. So if you don't have any more questions, I think we should wind up the workshop. First of all, thank you to everyone for registering and attending this workshop. And like I indicated to you earlier, um, I will be sending you an email which will contain the link to the recording, and we'll also have a discount for the KCD Chennai. And also you can look up for upcoming workshops in kcdchennai.in/workshops. And if you find any interesting workshops, you can register for them as well. Okay, so thank you so much, guys. I will meet you all in the next workshop. So the next workshop is about running machine learning models on Kubernetes. So this will be actually presented by me. So if you haven't registered for that workshop, you can consider registering for that workshop as well. So thank you once again. Thank you, Raman. See you all. Bye.
Thank you. Thanks a lot.